In this video, we're going to set up our Unity 2D project and add simple left and right movement to our player. So the first thing you want to do is install the Unity Hub. I will leave a download link in the description. You will go to the left-hand side at the Installs tab and install the editor. I would recommend using an editor that has the letters LTS. This stands for long-term support. And I would recommend being in Unity 6. I'm on 6.3, but as long as you're on Unity 6 or later, you should be just fine. Then you're going to go to the Projects tab and hit this button, New Project. You can select templates from here, and I will be using the Universal 2D template. You can call it project whatever you want here on the right-hand side. I will just call mine Platformer Tutorial, and I will create the project. And after about 6 to 7 years of waiting, Unity Editor should open up. I will just start by changing a few settings and cleaning up a bit. Here we have an input system. We will also be using the input system in this tutorial, but we will create our own. So I will delete this one. I will just quickly mention that this tutorial expects you to have a basic understanding of C# programming and using the Unity editor. If that is not the case, I highly recommend watching my other videos. I have a C# basics course and I have a brief intro to the Unity editor. I will leave links for those videos down in the description. And if you've been using the Unity editor before, you will already know this. But when you click play, it takes a bit of time reloading the domain and scene and doing all sorts of checks. And we will be testing our game a lot to see how it runs when we implement something new. So to save a lot of time, you can go here and press edit and then click project settings. Then on the left, you'll find the editor tab. You'll scroll down a bit and you can see here it says when entering play mode, reload domain and scene. Just change this to do not reload domain or scene. Now you can close this window out. And when you press play, it instantly starts the game without you having to wait for reloading. So now that we've got that done, I'll just take my game window, drag over here to the right. I like to see my scene window and my game window simultaneously. And I'll also change the display aspect from free aspect to full HD 1920 by 1080 pixels, as we will be making this game for a PC. Now that the basics out of the way, we can create our player. I will go to my hierarchy on the left-hand side, and I will right-click, go to Create, 2D Object, Sprites, and I will create a triangle. You can create whichever shape you want. I'll just use a triangle for mine. I will name it player, and we will need a few components on the player. We will need a rigid body 2D, and I will take off the gravity for now when we're just testing out the movement. And I will also change my collision detection from discrete to continuous to make sure it collides correctly with other objects when we add them further on. And now that we have our player, we can start to create our movement. I will go to my project tab, and in my assets folder, I will create 2 new folders. I will create one folder called scripts, and I will create another folder called input. This is just me wanting to be a bit organized. You don't have to do this. You can keep it all in the assets folder if you like. But for your own sake, it's going to be easier to find certain assets if you divide them into folders. And now we will create our own input system, as I mentioned before. We will right-click, go to Create, and I will click here where it says Input Actions. This will create a new input action system, and I will call this Player Controls in 2 words and in plural. If you double-click this, this will open up the Input Actions editor. You can see we have 3 sections. We have action maps, actions, and action properties. I will go through these one by one. On the left-hand side, we have our action maps. Think of an action map as a certain control scheme for a certain situation. So in this video, we're doing movement, so I will create an action map, which is called movement. But let's say you had other controls. Let's say you had a combat system and vehicle controls. You could create other action maps for this as well. And you can assign certain controls depending on which situation you were in the game. We will not be needing the combat and vehicle controls for this tutorial, so I will be deleting those again. It was just to show that you could create more if you'd like to. And now that we are in our action map, you can see we also have a new action in our action section. This is just created by default. So here, for instance, we can rename this new action to move. This could be one of our actions, moving. Another action could be jump, for instance. We will add that in a later video. We can go out here in the right side to the action properties. And here you can see the action type. It's currently set to button. I will change this to pass-through. And the control type, I will change to a vector 2. Since we're working in a 2D game, we want to use vector 2s. And if we click this drop-down arrow here, you have no binding currently. We will just delete this default binding. And instead, I will go to the little plus sign here and I will add what is called an up, down, left, right composite. You can see this adds a 2D vector, and if we expand this, you have your up, down, left, and rights, but with currently no bindings. We will only be moving up and downwards during jumps and falls, so I will be deleting the up and down bindings. Now we can set the bindings for left and right. If you click a certain binding, out here on the right in the binding properties, you can see there's this section called path. This is where you can set the bindings for your gamepad, your joystick, your keyboard, your mouse, whatever. What you could do is go into keyboard section and find the specific key, but it's actually much easier to just press this button called listen. And as we're moving left, I will press A on my keyboard, and you can see it finds the A instantly. And I will do the same for the right. Press listen, D, and now the left is added to the A on the keyboard and the right is set to the D on the keyboard. Before we close out this window, make sure to hit Save Asset. You might already have activated autosave, but if you don't, activate it or save the asset manually. Now you can close out the window, and when our player controls action input is highlighted in our assets folder, you can see here in the inspector it says generate C# class. We can tick this box and hit apply. This will generate a C# script called player controls. And I know this is looking very confusing, but don't worry, at no point we will open up the script or change anything in it. I'll just show you here if I scroll down a bit. It says the name of a class player controls, movement, which we've named our action map. It uses a 2D vector and we have a left and right. So it basically takes in whatever we put in the input action editor. And this is just what goes on behind the scenes in Unity. So you don't have to worry too much about this. I just wanted to show you that it actually makes sense, the stuff it says in here. We can now create our movement script. So I will go back to assets and into my scripts folder. I will right click and create a new mono behavior script. And I will call my script player controller. Not to be confused with player controls. This is a one word only and it's called controller instead of controls. Now, after that is done compiling, you can double click it to open it up. I will just start out by deleting the start and update methods. We will be using these methods later, but for now it's just easier to read if the script starts out empty. The first thing we'll need to get our player to move is some kind of speed. I will create a serialized field, which makes sure that we can keep our variable private, but still edit it outside in the Unity editor. And it will be a private float, and I will call mine move speed. I'll just set it to 5F for now. We'll also need the player controls class, which we've generated before from our input actions. So I will create a private player controls. I'll just call it player controls here as well. We'll also need some kind of movement. So I will create a private vector2. I'll call it movement. And if you remember before on our player, we've added a rigid body 2D component. We will need this component as well in our script, but I will show you how to do that in a bit. But firstly, we will use the Unity built-in method called awake. And here we will set our player controls to be equal to new player controls. As I said before, we will need this rigid body 2D component as well. But firstly, I would like to show you how to get a component. Let's say that we had a sprite renderer on a player. To get that component and use it on our script, we would create a private of the type sprite renderer. We can just call it sprite renderer as well. And then to get and use this component, I would go into my wait method and I would set sprite renderer to be equal to get component. And then inside the angle brackets, we'll name our type. We would like to get the sprite renderer, and then just parentheses and semicolon. Now we can use the sprite renderer class and all of its extension methods. But of course, we don't need the sprite renderer right now to make our player move. We will need the rigid body 2D. So that will be your first challenge of this video. Create a private variable for our rigid body 2D and get the component of the rigid body 2D inside the awake method. Pause the video now, give it a good go, and then you can come back to the video to see my solution. Okay, welcome back. We won't be needing these sprite renderers, so we'll delete these two lines. And instead, we want to get the rigid body 2D. So I will create a private rigid body 2D. I'll just call it rigid body. And then inside awake, I will set my rigid body to be equal to get component. Which type would we like? We would like a rigid body 2D, and then just parentheses and a semicolon. Now the next thing we need to do is to make sure we can use our player controls. To do this, we must enable it. Luckily, Unity already has these methods. We will use the method called onEnable, and inside this onEnable method, all we need to do is type the name of our variable, player controls, .enable. And good practice is that when you enable something, you also have to disable it. Unity has a method for that too. It's called onDisable. And just as we did in onEnable, we'll just type player controls dot disable. Now the next step is to make sure that our input is registered. We will do this in the method called update. This is called once per frame. So if your game runs at 60 FPS, then it will be called 60 times per second. And here is where we use our movement variable, which we created before, the vector2, and we will set this to player controls, our player controls variable, dot movement, dot move, dot read value, and we want to read a vector2. I know this line can be a bit confusing. Let's just go through it. Where am I getting all these words from, like player controls and movement and such? Well, if we go back to the Unity editor and we head into our input folder, and here is our input system, you can see our input system is called player controls. Our action map is called movement. Our action is called move, and it is of the type vector2. So player controls, our input system, movement, our action map, then our action called move, and we read the value from a vector2. And to visualize even further how this works, if we were to set a debug.log, so we can see our logging in the console, we can just log our movement variable .x. Let's save that, head back into Unity, and make sure before you start the game that you go to our player game object and just drag in the player controller script. I will just open up my console window, and you can see now that when we play the game, it constantly spits out 0. It does that each and every frame. That's because right now our movement.x is currently 0, but when I hold down the D key, it will change to 1. And when I hold down the A key, it will change to -1. And if I don't hold down any keys at all, it'll just stay there at 0. So by pressing the A key, we give the movement.x a negative value, and by pressing the D key, we give it a positive value. If we move the player around in the scene view, you can see here it's transform the position.x. If I just drag it here to the left, it'll give it a negative x value, and if I drag it to the right, it will give it a positive x value. So now that we know our input is registering correctly, we can remove this debug log. We won't be needing that anymore. And we can now go into the Unity method called fixed update. I am using both update and fixed update, as usually update is the best way and best practice to register player input, while fixed update is the best method for handling physics. In here, we will be accessing our rigid body variable, and we will use the rigid body extension method called move position. You can see here from the description, it moves the rigid body to a position, so just what we want to create movement. And inside these parentheses, we will need a few parameters. We will need our current position. We will also need which way to move, so some sort of direction. And we will need to multiply this with some sort of speed, and we will need to multiply that with time. This is a very hard challenge, and if you have no idea what to put here, I don't blame you at all. I just wanted to give you guys an opportunity to try this out for yourself and see if you can figure out what we need in the different positions. Again, we need 4 things. We need the current position, we need where to move, we need our speed, and we need the time. So if you'd like, you can pause the video, give it an honest effort, and then come back and see my solution. So now let's put in what we really need. We need the current position, and that would be the current position of our rigid body. So rigid body dot position. Here we would need to add which direction to move. So we would be using our movement variable, because remember, this registers whether we are moving in a positive or a negative direction on the x-axis based on the player input. We would need to multiply this with some sort of speed. That would be our move speed. Remember the float we've set right here at the very top, set to 5f. And we also need to multiply this with time.fixed delta time. We're using fixed delta time because we are in fixed update. If we were to use this in update, we would just use time.delta time. And the last thing I want to make sure is that our script is nice and clean. Here in update and fixed update, these can get clogged up really quick when we add some more code further on. So I would like to move these 2 blocks of code outside in their own separate methods. There's 2 ways to do this. You can either highlight the block of code that you'd like to move out, hold down left control and press the period sign. This will bring up a small menu, and as you can see, it says extract method. If we click this, this will create a new method, and we can call this player input, as it registers the input of the player. And now you can see here we have a new method called player input, and that is called inside of update. The only problem being that this is put right underneath the update, and I like to keep my own created methods separate from the Unity built-in methods. So I'll just cut this out and paste it underneath fixed update. And the other way to create a method is just to take this block of code, cut it out using Control X, and you can create your own method. I will create a private method, returns void. It's called move, and inside the block of code, I'll just paste what I've just cut out. And then inside fixed update, we will make sure that move method is called. Now we can save the script. I'm now back into the Unity editor. I'll just blow up my game view, hit play, try to press D, it moves to the right, try to press A, it moves to the left. So well done on this video. I hope it helped you out. If it did, please consider hitting that like and subscribe button, as this helps me out massively. And thank you so much for watching.